Hello, everybody, and welcome to our webinar. My name is Ciprian Tibia, and I will be your host for today. Today, as you found out from the description, this is an introduction webinar for new users in particular, but also existing users might learn a thing or two about our software and what you can do with it. So I'm having like a very short brief overview of some of the projects made in FEM-Design. And FEM-Design, as you are well aware, is our global analysis software, and beside FEM-Design we have a few different other software as well. Here are just a few of them. So for structural we have also diamonds. We have element design software like WinStatic, Simplex Beam, Yigi. We have precast element and prestressed elements with prestress. And we have BIM software as Impact, which can be used both by design and design offices and factories. So yeah, this was the short introduction. We are a company that is coming from Sweden, and in our portfolio we have like a lot of software, different software that you guys can use in your day-to-day work. So yeah, this is the interface of FEM-Design for those of you that haven't had any contact with it. It's quite intuitive and quite easy to use, similar in many ways with AutoCAD interface, for example, and everything has the logic from left to right. So if we go on those tabs, you see the first tab is structure, which has stories, axes, structural elements like columns, beams, walls, plates, etc., supports. And then logically you move further into the loads tab, then the finite element tab, analysis, and then the design modules. All right. Here you have like layers, exactly as in you have in AutoCAD. You can hide them, you can lock them, you can view them. So that's why I said that everything is intuitive. For today's webinar, I want to show you guys how to import an IFC file, because I know lately most of us are dealing with complicated architectures, or you just want to save time, and you get an IFC file, you don't want to start modeling from scratch. So for that particular reason, we go file open and we select IFC file, and then we select the file that we want to import. Now, of course, here, if everything is mapped in your IFC file, is really easy when you do the importing. You can rotate the global axis, you can move the model if it's not okay, and you can choose which elements you want to import. For example, I don't want to import the stairs for this model, right? So I just unclick them, and then it goes to element filtering. Then you can choose like the default material, or you can select the material for the imported elements. And of course the sections as well. And assuming that everything is okay, you click the import. Now, once you import it, you get this message. In case you have warnings or errors, you will get them displayed here. This is our model. And whenever you import from an IFC file, because you basically import some three-dimensional elements into plane elements like you know, bars and shells, you get those irregularities or things that you need to correct. But luckily, it's really easy to correct them in FEM-Design, and yeah, we'll take you to a very simplistic project in this overview. So we will delete the unnecessary access. Then we take a look, and we see that we don't have any stories. So we will try to implement some stories. Let's see. Yeah, 0.5 seems to be okay. Then we take a look. We have like the stories implemented, and we can see them here. Now, next thing that I want to do is go through each story and yeah, make sure that you know, our structure is okay, or if I have to do some other modification. And immediately I see that the columns are like not divided, right? So yeah, I can use like this modify tool, and I can just click divide, you know, and then I can click okay, divide them in 3. And now I have like the division for them. And yeah, let's have a look at our axis as well. So a view from the top, and then I probably need to add some axis, right? So I click the copy, and I just copy the axis. All right, seems to be okay. And now the next thing that I do, I have here like the adjust the analytical model. Now I'm going a little bit slower, of course. After you master this technique, every importing of any model goes really smooth. So yeah, you have to align any objects to stories first. So we just select everything, and I have a tolerance of 0.5 meters. So now I see that those have aligned, most of them. Then I want to align them to axis. All right. Then I will go and say fit any objects to stories. All right. And let's see this one. Yep. All right, so now it looks okay. It's not quite yet okay. And we select this one, fit to each other for the roofing part, because as you see, we have some gaps. So if I select front view, I notice that I have some gaps and I want to close those gaps. So yeah. And let's see now. Now it looks okay. All right, so this was like the first thing that we did with the adjust analytical model. Those are, let's say, rough corrections that you can do like on a very misplaced model. The next step would be to go to the automatic correcting tool, and is this one over here, correct model. And now I select everything, and we select start, and it's like a predator targeting system. It shows you which element was targeted for fix. And I say, okay, fix, or I can just click fix all from the get-go. Right, and I say, okay, fix all. Oh. Fix all, and yeah, 0 point, okay. Maybe I should set it a little bit smaller, and now it looks okay. Apply. All right, and now I have corrected the model. I have removed like unnecessary parts of the wall which were too small, and everything looks pretty much okay. What we can do, we can check the finite element, but before we do that, I would like to add some supports to our model. So yeah, I'm just locking away the stories and axes. And this is the support tab. Now I have this point support tab, which I can click it and select endpoints, right? And I can just go like this, and only the columns have been point supports have only been added to columns, because the other ones are line supports. So then I go to line support, and I do the same thing. I select everything as easy as this, and I see that supports have been added to all my walls. All right. Now I can generate a mesh, and yeah, check how the mesh looks, and everything looks fine. The mesh is yeah, looking really good. So if everything is okay, we can move further. So for loads, and we need to define some loads. So by the way, if at any point you got questions, you have a question field where you can text me your question, and either we will respond at the end of the webinar, or we will respond by email, but your question will not remain unanswered. So I encourage you at any point, just yeah, ask away. There is no such thing as a stupid question, so don't worry. live load, and yeah. I just added those two because for the sake of example. Now, of course, I can just fit them directly, or I can do some other thing. I can convert this roof into a cover, and I have this button like convert. If I click it, it was automatically converted, and supporting structures are selected automatically, so it will automatically detect my supporting structures. And I do the same for the other one. Good. All right, and yeah, now I can define my loads. So let's add the live load. Because the permanent, we already said that it's plus structural dead load, we can add in a permanent load as well, even in that case. So we just say surface load and pick existing region. So it's quite easy. Now you've added your load. All right. You can do the same for, the permanent load, and you can switch like the values. All right. Now you can generate load groups, and then if you assign all your loads to the right load group, you have the ability to generate the load combinations afterwards. So this is the load group, and we add a group. We say permanent, and type is permanent, and then we just drag and drop it like this. And then you have like the used coefficients here. And then you can add a live, and we drag and drop the live load, and we select that it's temporary, and here you have like office area, residential, etc. So, and with the corresponding coefficients, of course. Now you can do this for the wind, for the snow as well. I will show you how to generate wind and snow load later. All right, now we click OK. We go to load combinations, and we click the generate button. And here they are with the corresponding coefficients. We say OK. And we can go to analyze. Now, here I can select load cases, load combinations, setup. I can select them or unselect them depending on how easy or complicated I want to make my analysis. And I just click OK, and yeah, the analysis is working, and it will give me my desired results. So this was like briefly how you can import an IFC model, how you can correct it manually in the beginning, then using the correct model tool. We have a designated video. One of our colleagues in Hungary is importing like a really interesting, from an architectural point of view, building with a lot of errors, and he's correcting it you know, like really fast. And that video is only dealing with this topic alone. So now here I have in the quick tools, I have the results tab, and you know, I can view the results. I can look like how my building is deforming, the reactions, the bar internal forces. So everything is here, and you know, I can choose how to visualize it, like you know, graph or like colors. So yeah. Now I would like to move a little bit further away and open a new model in which I can show you how to model and design a very simple structure, and how to use the you know, automatic design of columns, of beams, of punching shear. Yeah, and then we can make another a very easy model where we can learn how to generate wind load, how to generate snow load, and so on and so forth. So yeah, I have an empty model, as you can see, and I select the columns first, and I want to have like the bottom point to be my anchor. I just selected this snap. So now I have like let's see, 1, 2, 3, and then if I want to copy them, I can easily do that. I select the copy base point, and I just carry them away, right? So 1, 2. Okay. Now we can, yeah, let's do that. Let's do it with no beams, and so we can see it like the punching. So I added a plate. Now I can add the supports. I want to see, because I just went with the default, so I have no idea what type of columns do I have. So let's see. I have an IPE. Let's place like concrete square, and the material does not match, so let's pick the material as well. All right, so now we have all concrete. Of course, I can visualize it like this as well. Then it's easier to spot like the sections. But for some reason, I always like to work with lines and shells. All right, then let's move into loads and add quickly some loads. And then we can do the load groups. It's okay, don't have to rename it. Good. All right, and now let's add some surface loads. And 3. Okay. And now let's see what we have. Loads. I have to generate the loads combination. Sorry. I almost missed it. as you can see in that analysis tab, we will go back to it. We have like a multitude of analysis types: eigenfrequency, seismic, footfall analysis, moving load, time history, you know, story fundamental frequency, and so on, imperfection analysis, construction stages. Yeah, there are a lot of analysis types, and they are all used in different scenarios. I can maybe quickly show you at the end how to perform a very simplistic seismic analysis if it's, you know, of interest to any of you. So now we've done the analysis. No, that's it. All right, so this is the way it deforms. Cool. Now I want to see some design. So yeah, we go to concrete, and we can do this automatically. So I can just click this and pick the auto design tool, then click OK, and it will calculate my reinforcement. Apparently my loads were a little too high. So yeah, happens when you are. Yeah, so I can choose to display it like this if I want a three-dimensional view of the reinforcement. I can also look at the punching shear reinforcement, and this one could not be designed probably from the same reason, that my loads were a little bit too high. But yeah, this is how it looks like when it can be designed. And of course, I can choose like what type of punching shear reinforcement I want to use. I want to use like Baco. I want to use like made on site. So we have like different types of punching shear reinforcement that can be used. And of course, you can, you know, have like a detailed view and see the calculations. You can check the utilization rate for each element, and then again, every view can be then added to our documentation. So it's quite intuitive, as I said in the beginning. Now let's take the last model, in which I will show you how to create an easy structure, how to copy stories and loads, and how to generate the wind and snow loads. So again, I will choose the general Eurocode, and let's go with something like a mix. It's columns, and let's do it like this, and with walls. Of course, I went a little too far. Yeah. Have a lot of tabs opened, so that's why. All right, and let's make a door here. Of course, these cutouts, you can make them by coordinates or you know, by grid if you made your grid in a very good way. And now let's place like a plain plate. All right, and maybe add some beams. Let's see. So here I can choose how is my beam connected. So let's make it hinged. And yeah, let's add some beams. Okay. And now let's support our structure. And to do the same for the lights. Thank you. You already got it so far, so probably by the end of this webinar, you'll be more experts than I am. Okay, and let's add the load. Whatever. And let's make it 3. Okay, so now I have like probably one story of a very rectangular building, but I don't have any stories or axes, so let's place some stories, right? And I want some stories, maybe 3 stories. Okay. And now I want to use this copy story function. So what does this function do? Well, basically, I select the source, and then I select where I want to copy it. And this checkbox here asks me if whether I want to copy the loads or not. So let's copy the loads as well. And the smart thing about it, now in this particular case, I made 3 meters for all, right? But even if I do 2 meters for the last floor, it will still copy and adjust the floor. So same source, different one. And as you see, it got copied with the correct height. The loads are also there in the right place, so they got copied as well in a very good manner. So I said that I will show you how to generate wind load and snow load. So the first thing that we want to do, we want to use this cover. So we want to use the wall cover, and let's make it 8 meters, I think is the height of our structure. Yes. So we can do those panels. Let's make it like this. On the full height. Or we can make them individual. It's up to me. It's up to the complexity of the geometry as well. So you see that FEM-Design automatically detects the supporting structures and makes the appropriate division of my cover. And then the roof part. And now we're good. Okay, so now I have a fully covered building. I can go to the next phase and use this one in order to tell the software which is the exterior part and which is the interior part. So I just click outside it and you see it's external wall. All right, then I got roof. Perfect. And now I have defined also the exterior and interior space. I can go to this wind and use this one, like wind speed, the area, if weather is protected, is by the sea, it's yeah, in a crowded city, or and I can visualize it like this, or let's see, or I can go and click generate wind load. Okay, and then it will automatically generate me like 16 cases of wind. So you can see here, X plus, direction 1, direction 2, minus, Y. So everything was automatically generated, right? And it works the same for snow. You know, for snow, you can click to open this tab and to select how is your building geometry, if whether you have roof differences, if whether you have you know, agglomerations of snow in some parts, and select the appropriate one, and yeah, just generate the snow load afterwards. So yes, this was like how you can generate wind snow load. And I said that I will show you how to do a quick seismic analysis. So yeah, let's do that. Let's close this one because it's such a big model. Right, and first thing that you need to do is basically go to this load to mass conversion. Maybe we can do the other model, and we can quickly adjust it, or no, let's stay here because we have stories. We need stories for seismic. So in this load to mass conversion, basically what you do, you choose a factor which you will find in your national annex or in Eurocode, and how much of that load is converted into mass. So let's say 0.4 for this load, right? And then you go to this seismic load tab, and you look at the factors, you know, the behavior factor and the damping factor, and to your horizontal and vertical spectrums. And afterwards, of course, you can, if you have an Excel file, you can also do it like this, right? So you can define it by points, or you can define it by corner periods. That's up to you. And assuming everything was okay, you go to Analysis tab, and prior to running a seismic calculation, you need an eigenfrequency calculation as well. And usually it's like X and Y. You don't look at the Z direction. And I'm trying to have like over 90% of mass participation. And afterwards, you basically select the dominant vibration shape you would choose, and you are ready to run your seismic calculation. So now if I go to Seismic and I click Setup, see I have this mass participation percentage. So definitely this is my dominance, because I have 72.4% on X in this first vibration mode, and 88% in the second one for Y. So yeah, I click OK, and yeah, now it's running a very basic seismic calculation, and I can look at I can even animate it, and yeah, see how the movement is happening during a quake effect. Yeah, so let me see if I have some questions here. Oh. You guys have been very silent, as I see. My question tab is empty. I hope I was clear, and I don't know, in my in the way I presented, so everybody now has like a better understanding on what is FEM-Design, how can we use it, what can we do with it, and yeah, of course this is just a glimpse into very complex software, and I just showed you like a very few ways on how to build a model, how you can run an analysis. Of course, there are so many analysis types that yeah, one webinar alone is not enough to go through everything. And then, of course, there is different materials like steel, concrete, composite, timber, CLT, etc. But we have like a very complete database of webinars on YouTube, on GoToStage, and everything which is recorded, it's afterwards uploaded there. So therefore, I encourage you to apply for a trial if you haven't tested FEM-Design. We are here for you to support you, like live or through a Teams call. And you also have like this huge and free database of knowledge, which is basically at the reach of your hand. So yes, without further ado, thank you very much for participating. I hope you enjoyed it, and I'll see you in our next webinars. Have a great day. Bye-bye.